Hi, good afternoon. My name is Xavier Arzaga. I'm a toxicologist with NCIA IRIS. This afternoon we'll be talking about evidence evaluation and starting off with evaluating evidence from individual studies, reporting quality, risk of bias, and sensitivity. Oh, sorry. Yeah. Xavier Arzaga, Andrew Kraft, also toxicologist from NCIA, Barbara Glenn, epidemiologist, NCIA, Beth Radke, also epidemiologist, Catherine Gibbons, toxicologist, mechanisms, right? And Chris. Thank you. All right, so in the 2014 review of the EPA IRIS process, the National Academies stressed various aspects about evaluation of epidemiological and animal toxicity studies. In it, in the report, in the review, the NIS stressed that EPA IRIS identify factors that can contribute to bias in epidemiological and animal toxicity studies, that we select or develop a method that is transparent, reproducible, and defensible. Also, that the selected method should consider study factors that are known to impact the direction or magnitude of the evaluated effects, and that the specific that we should also specify the criteria that is used for risk of bias analysis in the different lines of evidence and studies. Finally, that the tools and results of these evaluations should be made available and also become part of the IRIS tox reviews. In response to those recommendations, we've considered and drawn from existing tools for study evaluation. When we've developed approaches for both epi and animal tox studies that address the study sensitivity and identify potential sources of bias in the studies, that transparently present criteria or considerations that are used to evaluate and judge the studies and the outcomes that are reported in it. I would stress throughout the presentation that the approaches that we developed are outcome specific, and also provides access to the rationale for discipline-specific decisions made during the evaluation process, so that the audience can see why was the reason that a study was considered high, medium, or low in confidence. The overall objective of doing this practice is to identify those studies that are most informative and reliable that would then move forward for evidence synthesis and integration. We've also considered approaches for the evaluation of mechanistic studies, and those we'll discuss further ahead by my colleague, Catherine Gibbons. And then we'll be talking primarily about animal tox and epi studies, but we do also evaluate PBPK models when they're available in the literature. The table that is presented here shows the criteria that we use to evaluate published PBPK models. It's busy. I don't expect you to go through all of it. I just put it in there to remind myself to tell you that a more detailed description of the criteria is presented in one of the posters that you can see later today. The poster is titled Systematic Evaluation of PBPK Models for Human Health Risk Assessment. Also, wanted to remind you that the approaches used for evaluating PBPK models are captured in the EPA response to the request for correction of the IRIS toxicological review of chloroprene from this year. There are various tools that are out there in the scientific literature that are used for evaluating epidemiological and animal toxicity studies. Our staff has considered a few of these. And specifically, we've done trials with NTP-OHAT and ToxR and some of our staff has also participated in the development of some of these approaches, specifically the Science in Risk Assessment and Policy tool, or SIRAP. After considering and learning quite a bit from all of these methods, the IRIS program has developed its own approach for evaluating human and animal studies. In general, the approach for human and animal tox studies is similar. It considers three different aspects. One is internal validity. Here we're asking whether there's any methodological issues with the studies or whether there's any aspects that may have introduced bias into the study. Sensitivity, what we're trying to get to here is whether the study was developed accordingly and used appropriate methods to detect the response to exposure to a given chemical. And reporting quality, which basically what we're trying to find out here is, do we have enough information in the published study that would allow us to do an evaluation? The questions that are captured in the IRIS protocol template highlight general study attributes or elements to consider. However, it's important to remember that subject matter knowledge is used to formulate a list of issues to consider in the evaluation. And as you do that, incorporate that subject matter knowledge, we develop a set of considerations that are based on exposure and outcome-specific knowledge. So for instance, if you're evaluating neurotoxicological and reproductive effects, those considerations will want to see certain things in a reprotox study that are maybe not as relevant in a neurotox study, and vice versa. So it becomes more discipline specific. I should also mention that if IRIS does not have knowledge in a particular field of expertise, we do reach out to our colleagues in the Office of Research and Development, as well as other federal agencies and outside groups in the broader scientific community. The diagram here presents a flow of the process for evaluating individual animal or EPI studies. And for animal and EPI, the process is divided into several domains, which are looked at by the scientists doing the evaluation. Once you complete it and doing the evaluation for each domain, we do an overall study rating, high confidence, medium or low confidence, or uninformative. Here I'd like to also remind that the approach is outcome specific. So there may be differences in the domain judgments or the overall study ratings for studies that report on different effects. So a study may be really well designed to look at hepatic outcomes, but even though it reports on, say, male repro effects, there may be some issues that were identified that would reduce your confidence in that particular domain. So that's something to keep in mind, that it's outcome specific. For the individual domains, we have 4 different judgment calls. Good is when, for that particular domain, the study is considered of appropriate conduct and there are no issues that are identified. Adequate is when there might be some limitations, but they're not expected to impact the results. Poor is when we identify sources of biases or weaknesses in the study that may have an impact in the interpretation of the study findings. And critically deficient is when we identify a flaw that is so severe that basically the study is unusable at that point, and we wouldn't move forward with it. Once you're done doing the evaluation for all of the domains, we then have an overall call for the study, high, medium, or low confidence. High is when there's no deficiencies or concerns identified. And the study. Medium is when there's some potential deficiencies or weaknesses in the study, but they're not expected to introduce a significant bias in the study. Low is when those deficiencies or any issues that are identified may have an impact in the sensitivity of the study and the interpretation of the study results. And finally, uninformative is when the flaws that were identified are so serious that we wouldn't move forward with the study. It becomes unusable at that point. Later on, you'll see some of the tools that we use to perform these evaluations and capture them, the different calls. But I want to say also that for each of these, we capture the rationale behind these decisions for the domains as well as for the overall study. And so that process and that documentation is also available to the audience. And then finally, this is just wanted to go over quickly the domains that are used for evaluating animal studies. So we looked at reporting quality. Does the study provide enough information for us to evaluate it? Selection or performance bias is whether the investigators took any steps to reduce observational bias, things like randomization, blinding. Confounding or variable control refers to whether there are any outside variables that could have had an impact in the experiment. Things like, a severe example would be a study that reports that some of the animals were sick. Reporting or attrition bias, exposure methods sensitivity. Was the study designed to look at liver effects, or was it designed well to look at reproductive effects, and so on? And outcome measures and results display is the study look at endpoints that are considered well-established and informative for the outcome that you're interested in evaluating. Before I pass it on to Beth, I wanted to make a quick announcement that in the posters that you'll see later this afternoon, we capture, specifically for the ones for phthalates, we capture the process of evaluating epi and animal studies, as well as some of the visualizations that result from this process of study evaluation.
Okay, thank you. And I'm going to talk about the epidemiology side. So for epidemiology, we started with an approach that's based on the Cochrane risk of bias and non-randomized studies of interventions, or Robbins-I. And this is a very well-respected tool. It's been cited over 200 times since it was published in 2016. And we just wanted to modify it so that it was more appropriate for environmental and occupational exposures. And there's actually also another effort underway to do that, to create a Robbins-E tool that some of our epidemiologists are involved with. So with this approach, we start by considering what an ideal study would be to evaluate each domain for the specific research question. So how could we design a study that would be completely free of bias? And then from there, go to the other end of the spectrum and think, what are the critical deficiencies? What would be so severe a bias that we would want to exclude the study altogether? And then we just flesh out the levels of confidence in between those two extremes to think about what are the outcome and exposure specific criteria that we would consider good, adequate, poor, etc. And throughout this process, we're really focused on identifying bias that would produce a substantive change in the effect estimate. So we're not trying to exclude all the studies that don't have a perfect study design, but when we do include a study, we want to make sure that it's appropriate and informative. These are the epidemiology domains. You can see that they mirror fairly closely the animal toxicology domains, but we just have different considerations due to the differences in studying people and animals. They behave differently, we can't dose people, so we have to think about things slightly differently. So the first one is exposure measurement. So how confident are we that the people we're saying are exposed are actually exposed, and the unexposed ones are unexposed? Is the timing of the exposure appropriate? Does it actually, is what we're measuring reflective of exposure before the outcome develops? Similarly, for outcome ascertainment, are we concerned about misclassification where people are being put into the wrong bin? Population selection, is there any bias in how people are selected that could produce an effect that isn't a true effect? Confounding and analysis. And then lastly, looking at study sensitivity. And some of the study sensitivity issues that you can imagine are already covered in the other domains. And so this is really just a catch-all for anything else, like if the exposure levels are very low or the sample size is very small, we would expect that to decrease the study's ability to observe an effect, and we would want to make note of that when we were interpreting the results. So for each domain within that I just went over, there's a core question that's really what is that domain trying to get at. And then in our materials, in our handbook, and in our protocols, you'll also see these prompting and follow-up questions for each domain. So I'll just, these are available for you to peruse. I'm only showing you exposure, but there are similar questions for each of the domains. So that's just a quick look at what epidemiology looks like. I'm also going to give you some screenshots from the system that we're using for documentation of study design, which is called HAWK. We're going to get into more HAWK later, so I'm just going to be talking about the study evaluation piece. And the first point I want to make about HAWK is that it is not an automated system. So we were talking about some automation for screening. That's not the case for HAWK. This is really just a database. It's a nice interface that we have two independent reviewers enter their evaluations, and then it also gives us the ability to do conflict resolution. And I'm going to zoom in so you can see this a little bit better. But you can see that there are two reviewers, the ability to pull information from each of those reviewers, come to a final judgment for each domain. And we also have the ability within Hawk to customize the questions, the instructions, the drop-downs. So if there are assessment-specific considerations that we need to include, we can do that here as well. So this is just that zoomed-in view where you can see that we can pull information from both sides. Once the study evaluations are entered, we have a few different visualizations that we can produce in Hawk. These donut figures are for looking at individual studies. You can see the rating for each domain. And when you're in Hawk, you have the ability to click on any of these domains and then get a little box that gives you more information about the rationale for the rating. We also have visualizations for looking at cross studies. So here's a heat map where you can see the studies on the top and the domains along the side. We could use this for either epi or animal studies, just like the previous figure. And this is just a nice heat map. It gives you a snapshot of what the database looks like. This would just be a small database for of outcomes, or small database for an outcome, but it certainly could be much bigger. And we're still working on refining this figure. We would like to be able to add some more nuance, like the direction of the anticipated bias, which will help when we carry the study evaluation results forward into evidence synthesis. And so those visualizations are kind of what you can expect to see in iris assessments in the future. What's out there and publicly available now is going to look a little bit different. We have already started to incorporate study evaluation into some of our publicly available assessments, like the ones you see here, ammonia inhalation, RDX, TBA, and ETBE. In those cases, you'll see a table that documents the study evaluation. So that's sort of an early attempt, and now we're refining, and you'll start to see what those kinds of things that you saw in Hawk and the methods that we've described. So you can start to see that in the chloroform protocol, which was recently posted, as well as the chloroprene draft that we've talked about. So once we get through study evaluation, then we move on to data extraction, which can also take place in Hawk, and which we'll talk about in the next session. And from there, we go on to evidence synthesis and integration, which is what Barbara's going to start talking about now. So.